All right, so for this last example, we're going to sort of combine the elements we've learned so far. We're told that 2x plus 3 over x minus 1 is equal to negative 3a over 5, and we're told that a is equal to 5 square roots of 2. So I hope that kind of by looking at it, you can already see the similarity between this problem and the last two we've done. This one's just sort of more complicated because it combines both. But again, procedurally, nothing complicated. So I'm looking at this, I see that again there's two fractions. Fractions are hard to deal with. Let's just try to get rid of them. Let's just get it all in one line, right? So let's get rid of this one first. I see that there's a 5 in the denominator, so again, we want to get rid of the fraction, just multiply both sides of the equation by what's in the denominator. So let's multiply both sides of the equation by 5. So that means we have here 5 times this whole thing, right? So 5 times 2x plus 3 over x minus 1 is now equal to this thing, but the 5 got canceled out, right? We multiplied it by 5, this goes away, so we just have negative 3a. Okay. We can actually make this a little easier to look at because when you multiply by the fraction, right, you're just going to be multiplying it into the denominator. So we can actually rewrite this a bit like this. So we can remove that, and rewrite it as 5 times just what's in the denominator, right? Just like, if you had like 2 times 1 over 2, you'd be multiplying that into the top. You get 2 over 2, which is just 1. So now that we've done that, we can actually make this even easier to look at. We can distribute it in, right? We can distribute the 5 into this set of parentheses. So what would that give us? That would give us 10x, right? 5 times 2x, so this would be 10x plus, distribute that into there, plus 15. So once we distribute that in, 10x plus 15 over our x minus 1 equals 3a. Negative 3a, I'm sorry. So, okay, so we have this. Not bad. Looking a little bit better, but we still have this fraction, right? How do we get rid of it? Again, multiply both sides of the equation by what's on the bottom. Notice we have to now multiply it by this whole thing. So multiply both sides of your equation by x minus 1. Again, take everything in the denominator, multiply both sides by it. So multiply this side by x minus 1 and this side by x minus 1. So here it cancels out. So you'd get just this remaining on this side, right? So we just have 10x plus 15 is equal to this. We can rewrite this over here as, let me just move that over a little bit. So like this, right? We're just multiplying them together. So in this next one, I just already want to go ahead and distribute it in so I don't have to do an extra step. So let's just distribute this in. So negative 3a times x. So negative 3ax. And then negative 3a times negative 1. So then plus 3a. Okay. Not bad. So now we're here. What's our issue now? Well, we have a few of them, and one of them is that we have x, our variable that we're looking for, right? We have it on both sides of the equal sign. How can we sort of deal with that? Well, let's just get it on one side, okay? So let's add 3. Let's do plus 3ax on both sides of the equation. So plus 3ax. What would that give us? That would give us 3ax plus 10x plus 15 on this side, right, is equal to, this goes away, so just is equal to 3a. All right, so now we have our x's on the same side, okay? And what can we do next? Well, we want to isolate our x, but so let's just get rid of all the non-x related stuff from this side. So again, just get our x's on one, all the other stuff on the other. So let's subtract 15 from both sides of this equation, which would just leave us with 3ax plus 10x equal to 3a minus 15. All right. Okay, so I made a little space here so that we can continue. So now that we're here, we've accomplished putting all x's on one side and kind of putting all the other stuff, well, almost all the other stuff on the other side of the equation. So what's the problem here? Well, we have x in two different terms, and we can't actually just directly combine these terms. So what can we do about that? Well, I think in just the last problem we had a situation like this, right? So again, if you have x or whatever you're looking for in more than one term, you can just factor it out and then divide by what's sort of left over after you factor it out, right? So let's factor it out. If we factor out the x, we just have x times 3a plus 10, right? We divided both of these by x, take it on the outside. If you multiply it back in, you get this, right? So this is still equal to 3a minus 15. And lastly, of course, we just divide by whatever is left after we factor out our x, right? Because now our x is by itself, it's being multiplied by whatever. And if we just divide by this other stuff, we'll have x completely on its own on this side of the equation. So just divide by 3a plus 10 again in its entirety. Divide by 3a plus 10. So this cancels out right here, and that just stays like that. So in the end, you get x is equal to 3a minus 15 over 3a plus 10. All right, we're almost done. So on a quick note, you might be tempted to sort of cancel out the 3a's. Again, you can't do that, right? If you want to cancel stuff out, you have to divide each term on the top by the entirety of what's on the bottom. So it's not that simple. Just like we did here, right? There was only one term here, so we divided the whole thing by the whole thing. And it just so happened that these factors canceled out. So what do we do at this stage? Well, we have one more step. We have two variables, bit of a problem, but we know one of them. We know that a is equal to 5 square roots of 2. So let's just plug that in for a. So this, let me just continue it, is equal to 3 times 5 square roots of 2, right? Because that's a, minus 15 over 3, again, times a, 5 square roots of 2, plus 10, okay? So you've done that. You're almost at the finish line. Just multiply these two together right now, right? So now we can say that x is equal to 3 times 5 times square root of 2, 3 times 5, so 15 times the square root of 2 minus 15. And here we can have, again, 15 square root of 2 plus 10. So this is a perfectly good final answer, but there is actually a way to simplify this just a tad bit further. You see that, so right now you can't really divide or cancel anything out, right? But you see that right here, 5 is a factor of both of these and both of these, right? So what we can actually do is we can actually factor out a 5 on the top and bottom and then cancel that. Again, reason we can't do anything right now is because it's separated by a plus or minus. But watch. If we take this and we factor out a 5, so let's come over here, factor out a 5. So 5 times 15 divided by 5, right? So 3 square roots of 2 minus, again, 15 divided by 5. 3 over, factor out a 5 on the bottom, 3 square roots of 2, right? Then plus 10 divided by 5, 2. Now you have these two things that are separated by multiplication, and here you can cancel, right? These 5s will multiply out, and so you're left with just this. Can't really simplify that any further. You can't multiply these away. This has to stay this way. There's nothing else you can factor out to do any more cancellation, so this is going to have to be your final answer. So again, in this sort of extended example, what did we learn? So we didn't really learn anything new, right? We just kind of combined what we learned previously. So in summary, what did we do? We looked at this. We said that there are fractions. We don't like fractions. Just remove the fractions. Multiply both sides by the denominators to get it all in one line as much as possible. Or here we go, yeah, in one line. Once that's done, if you have an issue like having your variable in more than one term, factor it out and then just divide by what's left over. You have your variable isolated, plug in the a or whatever you might be given, and that's it. And something like this, so this is a pretty extended problem. You might not even see anything this difficult on the SAT math section in terms of just linear solving. So, but again, the reason I went through this example is to show you how to work with those skills, and this will be more useful to build upon for other kinds of problems, which again, we'll get to. So I hope that makes sense. I hope that the example was helpful. So I'm just now going to throw some practice questions at you, and you can go through those. Of course, I recorded solutions for every single one of them. So once you go through those, you can see how you did. And if you feel solid on this, which I feel like you'll have a grip on after you do, I don't know, maybe 3 or 4 more of these, you can move on to the next section.